Hello everyone. Right now I am here to talk about a little concept which is very tricky and people find it really difficult at times. So we are going to talk about aromaticity. I know people are known about the aromatic compounds and why is it actually existing in nature. But what compounds are generally referred as aromatic? So earlier when the discovery started, what happened was the aromatic, if I see the aromatic compounds which are generally existing in nature are the very pleasant smelling compound. So that's how the name aroma was included. So if you see the aroma which has been included in the aromatic compound is due to the pleasant smelling of those compounds. So now, and the one very big example which I know about is the benzene, that is C6H6. I know my benzene is aromatic compound, right? Everyone agrees with me? Benzene is aromatic compound. So how do I actually identify whether my compound is aromatic or not? So there are 4 rules which it should follow. What are those 4 rules? Let's see what are those 4 rules. For a compound to be aromatic in nature, what are the 4 rules to be followed? First one, it should be cyclic. What do you mean by cyclic? It should have a ring structure which is present in the compound. So, okay, the first situation is satisfied. What is the second condition for a compound to be aromatic? It should have conjugated pi-electron system. Pi-electron system, also referred by the name delocalization. So let me just try to explain the delocalization and conjugation with the help of my benzene ring itself. So if I see the benzene ring, I know there is alternating pi and sigma bond. So this is my pi bond, this is my sigma bond, this is my pi bond, this is my sigma bond, this is my pi bond, and this is my sigma bond. So that means alternating pi and sigma bonds actually means the conjugation, that is delocalization of my electron all over the ring structure. Perfect. So is this the only condition which satisfies, that is pi, sigma, pi? There can be many more conditions like that. I can have even pi, sigma and a lone pair. I can have this combination, or else even I can have pi, sigma and a charge, positive charge. So these all system will be in the category of conjugated pi-electron system. So okay, the first condition is being cyclic, second condition is being conjugated pi-electron. What is the third condition? Third condition is the molecule should be planar in nature. Now, planarity is something which will be given to you or taught to you from your teachers, because many of the compounds have very unusual planarity. At times it becomes difficult to comprehend that whether the compound would be planar or not. So in that case, I would suggest you to stick to the teachers, whoever teaching you, or stick to the books, whichever is you been referring, and there is certain thing which you can also comprehend in certain manner, like presence of only sp2 carbon. You know sp2 carbon, that means it's trigonal planar in nature. So it would be a planar structure, like in this benzene ring, every carbon which is present in the benzene ring is sp2 hybridized. sp2 hybridized means trigonal planar structure, thus this is a planar molecule as well. Okay, so What is the planarity? It can be either given to you or known to you, or you have read about it. So this is something which is very tricky and people generally tend to make mistakes out of it. So what my aim is to ensure whether you know the planarity of a molecule or not. We'll see it together. Okay, perfect. So what is the fourth and the foremost rule? The fourth and the foremost rule is the following the Huckel's rule. Now what is this Huckel's rule? Huckel's rule is that the 4n plus 2 pi-electron. So the n over here should be an integer. So on. N here should be an integer. So when I count the delocalized pi-electron system, then I will get to know how many electrons are present in it. So in the case of benzene itself, if I see, it has 3 pi bonds. So that means 6 electrons are present. So when I equate 4n plus 2 is equal to 6, then the n value comes out to be 1, which is an integer. So that means, what can I say? What all system actually will be following Huckel rule? That is 2n pi system, or else 2n pi and 6n pi, 10n pi, so on. These all system will follow the Huckel's rule. So I'm very much clear what are the rules to be followed in order for a compound to be aromatic. What are they? First one, it should be cyclic. Second thing, it should have the conjugated pi-electron system. Third thing, it should be a planar molecule. And the fourth one, it should follow the Huckel's rule. Very well, perfect. So let's try solving a question, and to be very certain that yes, I have understood what I am dealing with. So let's say I have been given this molecule. Let's say this. I have been given this molecule. So when I see the molecule, what do I see first thing? So what do I see? Does it has a cyclic structure? Yes, I can see it has a cyclic structure. Does it has delocalization? Let's see whether it has delocalization or not. Let's see. Pi, sigma, the charge, then sigma. Yes, it does have the delocalization. Perfect. What about its planarity? Yes, it is planar because every carbon which is present here is sp2 hybridized. Yes. Does it follows Huckel's rule? So when it comes to Huckel's rule, how many pi electrons are present? That means only 4 pi electrons are present, and n is coming as, and not as an integer, but it's coming as a fraction. So that means do not obey Huckel's rule. Right? Then what does this signify? So that means if the conditions are not satisfied, then the compound is said to be not aromatic. Now there comes another catch. What is the another catch? There are, apart from being aromatic, there are two more classes of compounds. What are they? One is anti-aromatic and another one is non-aromatic. So when I see these two terms, what is actually happening? In the anti-aromatic condition, the first three conditions are followed. That is, the compound is cyclic, the compound has conjugated pi-electron, as well as it has a planarity, right? All the first three rules are followed. But when it deviates from following the Huckel's rule, so when the Huckel rule is not followed, that means that compound becomes anti-aromatic. So that means this compound, cyclopentadienyl cation, becomes anti-aromatic in nature. Clear? So When I proceed further, so that means I can very well define organic compound into three broad categories. What are they? What are they? First one being aromatic, second one being anti-aromatic, and third one being non-aromatic. So I got three classes of compound in which I can classify my organic compounds into. So aromatic, I already saw the rule. It should follow being cyclic. It should follow being planar. It should have delocalization. And last but not the least, it should follow Huckel's rule. Perfect. So that means if all these four conditions are met, then the compound is said to be aromatic. Perfect. Anti-aromatic, the first three rules are followed. It is cyclic, it is a planar molecule, and it is what? It has delocalization as well. But where does it deviate? It do not obey Huckel's rule. Right? So that means what is happening? The first three rules are followed and the Huckel rule is not followed. That class of compound is referred by the name anti-aromatic. Perfect. Now what would be the non-aromatic compound? I've got aromaticity, I've got anti-aromaticity. Then what is non-aromaticity? It makes me wonder. So when I see what will be non-aromatic, it really doesn't matter whether the compound is following Huckel rule or not. It doesn't really matter over here. If, what is the if condition over here? If any of the first three conditions are not met, then the compound is non-aromatic. Perfect. So the three rules are clear to me. What are the three rules? First rule, aromaticity, that is, it should follow all the four rules. What is cyclic, planar, delocalization and Huckel's rule? Perfect. What about the anti-aromaticity? Only it does not obey the Huckel's rule. But the earlier three rules are followed in this case. Fine. Non-aromatic are the one, it doesn't really matter whether it follows the Huckel rule or not. Let it be the compound is following Huckel rule. But if it deviates from being cyclic, planar or delocalization, then the compound is referred as non-aromatic. Let's see an example and be very sure how are we dealing with the things. Let's see. So let's say I have been given three compounds and I need to classify them as anti-aromatic, non-aromatic and aromatic. So let's say these are the three compounds which is given to me. Okay, when these are the three compounds given to me, I need to see individually what is the condition. So let's go via the first one. So when I see my first molecule over here, it is a cyclic structure. Very well, it is a cyclic structure. But is it a planar structure? Now, So one condition which I mentioned earlier, in order for a compound to be planar, it should have all the sp2 carbons, but presence of a sp3 carbon makes them non-planar, right? So as you can see, this carbon over here is sp3 hybridized, right? So that means it's deviating from planarity. As well as if you see the conjugation as well, you have two sigma bonds together. So that means it's deviating from delocalization as well. So it doesn't really matter whether I check for Huckel's rule or not, as it has already deviated from two out of 4 rules which I've mentioned. That means this compound becomes non-aromatic in nature. Perfect. So that means this compound is very much clear that this is a non-aromatic compound. I hope nobody is having doubts stating that why is it deviating from planarity and why is it deviating from delocalization. Perfect. Now let's see what is happening in the next case. In the next case, what is happening is, this we have already done it. What is it? It is a cyclic structure. It is a cyclic structure. It is a planar structure as well, as all the carbons are sp2 hybridized. It has delocalization as well, right? It has delocalization as well. I can see the alternating pi and sigma. So pi, sigma, the positive charge, sigma, pi, sigma. So that means there is delocalization as well. Now, Huckel's rule, 4n plus 2 is equal to 4. So n becomes equals to half. That's why this compound becomes anti-aromatic. Clear? So that means even this is clear. This is an anti-aromatic compound due to the does not obeying the Huckel's rule. Let's see for this compound what happens in this case. In this compound, it is a cyclic structure, definitely. It is a planar structure as well. All the carbons are sp2 hybridized, right? Perfect. So what is happening? Delocalization. Yes, there is delocalization. Pi, sigma, the negative charge is actually like a lone pair, you can consider it. Sigma, pi, and then sigma again. So that means delocalization is complete. Now let's see whether it follows the Huckel rules or not. Huckel rule, in this case, 2 electrons of the pi and the 2 electrons of the negative charge. So that means, what does it becomes equals to 6. So my n comes as 1. So this compound is aromatic in nature. Perfect. So I have 3 different variants of the cyclopentadiene. In this case, I can see wherein there is no charge present, then it is a non-aromatic structure. Whereas when there is a positive charge, then it becomes an anti-aromatic compound, and when it's negatively charged, then it becomes the aromatic structure. So why is this so important to learn about aromaticity? Because in nature, aromaticity adds to the stability of that compound. The compound is very stable to exist in nature. So more is the so if the compound is aromatic in nature, I can understand that they are very stable, right? Their existence in nature is very much possible, right? Let's see one more example to be very certain whether I have totally understood this as well or not. So let's say I have been given 3 examples with the positive charge and with the negative charge. And I need to define these 3 compounds into the category. What is the category? Aromatic, non-aromatic and anti-aromatic. Okay, perfect. Let's see one by one. Let's go with the first one first. So when I see the first one, I see it's a cyclic structure. Right. After that, what do I see? Pi, sigma, sigma. So there is no delocalization. The delocalization condition is not met. As well as this carbon is sp3. So that means this is non-planar. So when a molecule deviates from any of the first three conditions apart from the Huckel's rule, then that class of a compound is referred as non-aromatic. Right? Similarly, let's see this case. What happens in this case? In this case, cyclic, yes. Delocalization, pi, sigma, charge, sigma, yes. Delocalization is also there. What else? The planarity. Yes, it's a planar molecule. All the carbons are sp2 hybridized. Does it follow Huckel rule? That's my question. 4n plus 2 is equal to 2. My n becomes equals to 0. Yes, it follows the Huckel's rule. Thus, this compound is aromatic. Perfect. So, I got to know if n is 0, that is that it follows the Huckel's rule. That means it is an aromatic compound. Fine. What about the last compound? Cyclic. Delocalization is there, pi, sigma, lone pair, pi, sigma, right? So, delocalization is also present. Planar, yes, it is a planar molecule. When I see the Huckel rule applicability, I see my n value coming as half, thus deviating from the Huckel rule. When a molecule deviates just from the Huckel rule, follows the first three, then it is an anti-aromatic compound. Clear? These were about the compounds which had no extra element. Now what are these extra elements? That is presence of sulfur, nitrogen, oxygen onto your compound. So when I see those type of compound, so that means one famous example which I can have is furan, pyrrole, and thiophene. So what do I see? In all these molecules, what is common is that it has a set of lone pair on it. Sulfur and oxygen has two set of lone pair, and whereas nitrogen has one set of lone pair. Perfect. So when I consider the aromaticity of all these three compounds, I am saying all these three compounds are aromatic in nature. Now you will ask me, ma'am, how is it possible? It's not possible because the oxygen, nitrogen and sulfur hybridization is sp3. How can you say it's a planar structure? Let's see how it is a planar structure. So let's imagine this one. This one is cyclic, very well cyclic. This one is delocalized. Yes, it does have delocalized system, but only one set of lone pair will be taken. Mind this. So pi, sigma, lone pair, sigma, pi, and then again sigma. We will not consider two set of. So while doing the conjugation, oxygen will be contributing only one set of its lone pair for the delocalization, not the both the set. So that's why for the Huckel rule also only one set of the lone pair will be considered for calculating for the pi electrons as well. Planarity. So for this you have to take my word for it, stating that this molecule is planar. So I told you, right, planarity will be either taught by your teacher or given in your book. Sometimes it is not very easy to predict the planarity of the molecule as such. Okay, so this is a planar molecule. Let's see about the 4n plus 2 rule. So 4n plus 2 becomes 6 electron. So n is equal to 2. Thus it follows Huckel's rule. Thus it's an aromatic compound. Fine. What about this molecule? Similar situation. Everything is same. But what is different? Nitrogen is present instead of oxygen, and nitrogen has only one set of lone pair. I need only one set of lone pair to form the delocalization, right? So that is enough. So that means even delocalization is possible. Planarity, yes, it is a planar molecule. So when I see the Huckel's rule, 4n plus 2 is equal to 6, n becomes equals to 2. So this molecule is also aromatic in nature. Clear? What about this thiophene? Cyclic. Same as oxygen. It belongs to the oxygen family. Delocalization can also be seen. What else can be seen? It is a planar molecule. Yes. It follows the Huckel's rule. I'll be considering one set of it. So that means n becomes equals to 2. So all these molecules are aromatic in nature. So I saw a compound without the extra element. I saw the compound with the extra element. What if I have given you one more example which goes like this? That one of the carbon in the benzene has been replaced by your nitrogen. So that means I am getting pyridine. This compound is referred by the name pyridine. So when I see this pyridine molecule, do you feel that this compound will be aromatic in nature? Let's think. Let's see whether is it aromatic or not. When I think about the aromaticity, cyclic, yes, perfect. Planar, yes, it is planar molecule. Fine. Delocalization. While considering delocalization, this is pi, sigma, pi. Now you'll ask me, ma'am, whether I should consider the lone pair on it or not. I don't need to consider it because it already has a sigma pi system. So there's no need to consider this. So when I am not considering the lone pair on the nitrogen, so that means that won't be accounted for the Huckel's rule as well. So Huckel rule will constitute only the 3 pi bond. So that means 6, my n value is 1. Yes, it is an aromatic compound. It is an aromatic compound wherein we haven't considered the nitrogen present on the lone pair present on the nitrogen, right? So in that case, I have understood that when to consider the lone pair and when not to consider the lone pair. Let's see another example. Let's say I have been given a fused ring. This is known as naphthalene. So in the case of naphthalene, what happens? In the case of naphthalene, the benzene ring has been fused from two points, right, resulting in the diring. So when I see this is a cyclic compound. Yes, it's a cyclic compound, and it has the delocalization as well. So when I see it, I know I can actually have pi, sigma, pi, sigma, pi, sigma, pi, sigma, pi, sigma, right? I can have the delocalization as well. What else? Planar. Yes, it is a planar molecule. But when it comes to Huckel rule, let's see what happens. 4n plus 2, right? 4n plus 2 is equal to 1, 2, 3, 4, 5, 6. 6 means 12 electrons. That means n becomes equals to 10 electrons. So my n becomes equals to 3. Thus naphthalene molecules are aromatic in nature. Very well, I got to know this. So now let me tell you an exception. What is an exception? So everybody knows there is a structure like this. This is cyclooctatetraene. So when I see this structure and I try to comprehend whether it's an aromatic, anti-aromatic or non-aromatic compound, when I try to judge about this thing, I see it is a cyclic structure. Very well, I can see it from the structure. Where it is a planar structure. Yes, you will say, ma'am, all the carbons are sp2 hybridized. We'll come to that question, but for the time being, yes, it is a planar. Does it has delocalization? Yes, it has delocalization. I can see sigma pi bonds alternating with one another, sigma pi, sigma pi, sigma pi and sigma pi, right? Does it follows the Huckel's rule? 4n plus 2 is equal to 4 pair, that means 8. 8 becomes n is equal to 3 by 2. So it is, so as per whatever is being denoted over here, this compound is anti-aromatic because it is deviating from Huckel's rule. But in reality, this compound is non-aromatic. Why is that? So in nature, this molecule exists in the form of a tub. Exists in the form of a tub, which makes it deviate from its planarity. So I told you planarity will be something which will be taught by either by your books or by your teacher or by your whatever you are referring into. So if I see over here, that loses the planarity, no non-planar. Thus, when any of the rule, the first three rule is not followed, then the molecule is non-aromatic in nature. Clear? So what all did we saw today? We talked about aromaticity. When we spoke about aromaticity, how it is actually related? It is related with the 4 golden rule. Let's just quickly recap and see what is the 4 golden rules are. What is the 4 golden rule? That is, the compound should be cyclic. First one, ring structure. Yes, it's a cyclic compound. It should have conjugated pi-electron or delocalization. That is, the electron should jump from one place to another. It is not sticking to one place. And that loop should always be complete. That it's coming back to its original position. That is why pi, sigma, psi, sigma. Right? Third thing, it should be a planar molecule. I mentioned it. Yes, planarity. Determining the planarity on your own, it's a difficult task. But yes, with the help of your teachers or else your books, definitely you'll be able to find out, as well as much as you practice. You know, the practice always makes you acquaint with lot of new compounds, and then you will become a champ or pro in aromaticity. So apart from that, the fourth rule, Huckel's rule. What is the Huckel's rule? That is 4n plus 2. The n value should be an integer, and the 4n plus 2 pi electrons are counted. In this, lone pairs are also counted. Mind this, right? So if I talk about all these things, scenarios and everything, so I think I am very well versed with the aromaticity. What is the purpose of aromaticity? Because it leads to stable molecule in the nature. Why is it important to know? Yes, because it classifies them into 2 major categories. I can say aromatic, not aromatic. Not aromatic will constitute 2 more categories, anti-aromatic and non-aromatic. Just like the 3 things which I have already stated. What are the rules to be followed? Very well known. 4 rules to be followed for the aromaticity. Anti-aromaticity deviates from the Huckel rule. That's it. It deviates from the Huckel rule. Apart from that, rest of it is followed. Then it's anti-aromatic. So what kinds of questions are actually expected? So you need to see whether the question has asked for not aromatic or non-aromatic. There's a difference. Not aromatic will constitute your anti-aromatic as well as non-aromatic. What it will include? These two will together will include not aromatic. So sometimes the question do arise in such a manner that they just tell you to find out which one is not aromatic. You really do not have to care about whether it's anti or it's non-aromatic. So to be sure and certain about, to read the question completely and know what exactly is being asked. You can also have a question which out of them is aromatic in nature. or else this compound is anti-aromatic. Which one of the following is not followed? This could also be the question. So these are the possibilities of the various questions possible from the aromaticity. It's a very simple concept. It's just that a little understanding of the organic compound is required. And I'm very well sure when you progress further and practice more questions, you will be able to achieve the target of knowing whether the compound is aromatic, not aromatic, or anti-aromatic, right? So on that note, I shall take a leave and we'll see you in the next class. Thank you so much.